students, now let's start our new chapter, chapter 11, network examples and protocols. In the previous chapter, we discussed about computer network. In this chapter, we are going to see about protocols of network. The main concepts you are going to learn in this chapter: network protocols, internet, intranet, extranet, mobile networks, wireless LANs 802.11 and RFID reference model. So first let us see what is computer network. A set of computers connected together for the purpose of sharing resources is called as computer network. The most commonly using computer network is internet. When we sharing the information between computers over network, some rules and procedures are used. That rules and procedures are called network protocols. Okay. So what do you mean by network protocols? Network protocol is the rules and procedures which allocates communication between more than one device which is connected to the network. Okay. This network protocols have to do end-to-end process of secure, on-time and managed data or network communication. It helps to provide secure end-to-end network communication. Okay. What do you mean by Internet Protocol? IP stands for Internet Protocol. The main function of IP is allows internet networking and boost up the internet. This Internet Protocol will takes the packets from the source host and it will deliver to the destination host via through an IP address in the packet's header. When Cerf and Bob Hornin in 1974 introduced IP connection, now the IP is referred as TCP IP Transmission Control Protocol, Internet Protocol. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. Next, let us see about types of networking protocols. There are three types of networking protocols: network communication protocols, network security protocols, network management protocols. Network communication protocols are basic data communication protocols. Example for network communication protocols are HTTP and TCP IP. Okay, Hypertext Transfer Protocol and Transmission Controls Protocol, Internet Protocol. Next, network security protocols. It implements security over network communications. For example, HTTPS, SFTP and SSL. Next protocols are network management protocols. It will provide network governance and maintenance. For example, ICMP, SNMP. Okay. Next topic is Internet, Intranet and Extranet. Internet is a global network, which means public network. Okay, public TCP IP network. It is used by over 1 million of people all over the world. Using internet, you can send email to your friend. That is the example for internet. See, internet is the public network, so anyone can share the data and information in the network. Okay, and the next one is intranet. This intranet is a private network. It may consist of many interlinked local area networks. This network with access restricted to members of an organization. For example, in your company, if you want to share your company data and details between the employees, you can use this intranet. See here, these are the employees, which means staffs. Here, if you want to share your company data and computing resources between the employees, you can use intranet network. Okay. Next one is extranet. This is also a private network. It is commonly used to securely share business information with the suppliers, vendors, partners, customers and other businesses. Okay. Next is see the network applications. These are the applications of internet. These are the applications of intranet. These are the applications of extranet. Internet is used to download programs, files, email, social media, e-banking, audio, video conferencing, and so on. The applications of intranet is sharing company details, accessing employee database, distribution of circulars, office orders, access office product and customer data, sharing of information of common interest, and so on. And the application of extranet is online education and training, account status inquiry, customer communications and so on. Okay. Next let us see about mobile network. Mobile network, it is also called as cellular network. A mobile network or cellular network is made up of a large number of signal areas. That signal areas is nothing but cells. It is also called as cells. Within each cell there is a base station which sends and receives the mobile signals. Okay. A mobile device will connect to the nearest or least base station. Okay. Communication over mobile network is made up of voice, data, images or text messages. Next topic is the generations of mobile networks. The mobile network generations can be divided into 5 generations. First generation, second generation, between second and third generation, second to third generation bridge, and next third generation, fourth generation, fifth generation. Let us discuss them one by one. The first generation, which means 1G network, was introduced in the year 1981. NMT launch. Here NMT stands for Nordic Mobile Telephone Communication. This first generation mobile systems are based on analog transmission. They had a very low traffic density of 1 call per radio channel and a very poor voice quality. And the second generation is 2G. Its year is 1991. GSM launch. Here GSM stands for Global System for Mobile Communication. It is the most popular standard which is used in second generation. SIM was introduced in the second generation. SIM stands for Subscriber Identity Model. It is used to authenticate a user for identification and billing purposes. And next second to third generation bridge, which means 2.5G. Its year is 2000. GPRS launch. GPRS stands for General Packet Radio Service. It was introduced in between 2G and 3G. This GPRS is a data service which enables mobile devices to send and receive messages, picture messages and emails. Through GPRS you can send and receive messages, picture messages and emails. It allows most popular operating speeds of up to 115 kilobits per second, laterally maximum of 384 kilobits per second by using Edge. Edge stands for Enhanced Data Rates for Global Evolution. Next third generation 3G, year 2003, first UK 3G launch. This generation of mobile systems merges different mobile technology standards and uses higher frequency bands for transmission and delivery data rates up to 2 megabits per second. It supports multimedia services such as voice, video, data. Okay. The transmission wire band frequencies are between 1900 and 2200 megahertz. Okay. Next fourth generation 4G. Its year is 2007. It is based on ad hoc networking model. Ad hoc networking requires global mobility features, which means mobile IP. This ad hoc networking is used to support an IP address for each mobile device. Its data rate from 2 megabits per second to 10 to 100 megabits per second. Okay. In this generation, mobile devices will not expect on a fixed infrastructure. They will require enhanced intelligence to self-configure in ad hoc networks and having a routing capabilities to route over a packet switched network. Okay. And next fifth generation 5G 2019 plus. This is LTE and WiMAX technology. It provides high data rate, reduced latency, energy saving, cost reduction and massive data connectivity. The two phases of 5G is release 15 and release 16. First phase is release 15 and second phase is release 16. First phase is completed on March 2019 and second one is expected to complete at March 2020. So it is called as IMD 2020 technology. It provides up to 20 gigabits per second speed. Okay. So these are the 5 generations of network And next one is Wireless LANs 802.11. Wi-Fi stands for Wireless Fidelity. It is a wireless network technology that permits computers and alternative devices to be connected to every alternative into local area network and to the net without wires and cables. This is the wireless network technology. It can be used to connect the computers or mobile devices without wires and cables. Okay. And the next one is RFID. RFID stands for Radio Frequency Identification. It is used for radio waves to read and capture information stored on a tag attached to an object. If you want to track the information of some products, you can use this RFID system. Okay. This RFID has been made up of two parts, a reader and a tag. So it is having two parts, reader and tag. The tag can be read the data from several feet away and it replaces the information from its memory bank. This tag having two parts, microchip and antenna. The processed information will be stored in the microchip and the antenna is used to receive and transmit signal. And the next part is reader. The reader will transmit to read the result to RFID computer program. Next, let us see about two types of RFID tags. The two types of RFID tags are active RFID system and passive RFID system. The active RFID system has its own power source. This system is used for larger distances and it is used to track high value goods like vehicles. Okay. And this passive RFID system gets power through power from a reader antenna to the tag antenna. This is used for shorter range transmission. Okay. The main components of RFID system is a RFID tag, a reader, a controller. RFID tag is nothing but it is a silicon chip. It is attached to the small antenna and mounted on a substrate. And this is the reader. It has scanner with antennas to transmit and receive signals and used for communication. And the next one, controller is also available. It is the host computer with a microprocessor which receives the reader input and process the data. Processing will be done in controller. Okay. Next topic is OSI model. OSI stands for Open System Interconnection. It was found in the year 1934. It was developed based on general set of gate lines. It describes the standard for intercomputer communication. OSI has 7 layers. What are they? Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are the 7 layers of OSI model. First one is physical layer. It is the first layer. It defines electrical and physical specifications for devices. And next one is data link layer. This is the second layer. It guarantees that the data is transmitted or free of errors. And the next one is network layer. It is the third layer. It is determining the path of data packets. And fourth one is transport layer. It is the fourth layer. It guarantees the transportation or sending of data is successful. It includes error checking operation also. Okay. And the next one is session layer. It is the fifth layer. It identifies the established system session between different network entities. It controls dialogues between computers. Next one is presentation layer. It is the sixth layer. It does the translation of data to the next layer, which means prepare the data to the application layer. Encryption and decryption protocols occurs in this layer. And next one is application layer. This is the seventh layer which acts as the user interface platform comprising of software within the system. Next topic is TCP IP. TCP IP stands for Transmission Control Protocol Internet Protocol. TCP IP is a set of protocols which governs communication among all the computers on the internet. This TCP and IP protocol tells how the information should be packaged, sent and received, as well as how to get it to its destination. Okay. Next let us see about TCP working. TCP IP is the combination of two protocols. What are they? Transmission Control Protocol and Internet Protocol. Internet Protocol specify the packets which have to go, where to go and how to get there. But the Transmission Control Protocol is accountable for guaranteeing the trustworthy transmission of data. It sees that the packets for errors and submits the request for retransmissions in case any of them are missing. Okay. The frequent TCP IP protocols are HTTP, HTTPS, FTP. HTTP stands for Hypertext Transfer Protocol. It is used between a web client and web server and it guarantees non-secure data transmissions. And what is HTTPS? Hypertext Transfer Protocol Secure. It is used between web client and web server. It ensures secure data transmissions. And FTP, File Transfer Protocol. It is used between computers for sending and receiving file. The different layers of TCP IP are Network Access Layer, Internet Layer, Transport Layer, Application Layer. These four layers are used in TCP IP model. The network access layer is used to build packets and the internet layer describes how packets are to be delivered. Transport layer ensures the proper transmission of data and the application layer performs application network processes. These processes includes file transfer protocol, hypertext transfer protocol, simple mail transfer protocol. And next topic is other network protocols. HTTPS, which stands for Hypertext Transfer Protocol Secure. It is a protocol where encoded data transfer on secure connection. It provides data security over the network, mainly on public networks like Wi-Fi. This HTTPS mainly deals with the financial transactions or transfer personal data where highly sensitive. Data exchanged between the user and the website is not stolen or not read and not altered by the third party. Okay. Next topic is domain names and TCP IP addresses. The address for any website is not easy as to remember, so we are using domain names. For example, see here, this is the address of Google website 216.58.216.164. This is not easy to remember. Its domain name is google.com. It is easy to remember. So, we are using domain names. Okay. This is about network examples and protocols. I hope you understand. Thank you.